world. You are welcome to Toydel online class. Today we want to continue from where we stopped yesterday. Yesterday we started revision. The revision on calculus. And we said we have the differential calculus, integral calculus. So we started with differential calculus, which is differentiation yesterday. So we started from the limit of a function. We introduced differentiation from the first principle, the normal way of differentiating a polynomial function. We talked about function of a function, and we stopped at derivative of a product, or what is called product rule. Today we want to start with quotient rule. Quotient rule, what do we mean by quotient? Product simply means, when you talk about products, it simply means multiplication. Product simply means multiplication. But when we talk about quotient simply means division. For instance, if let's say if y is equal to u all over v, where y, if y is equal to u all over v, where we have u and v are functions of x. So if y is equal to u over v, that is quotient, is fractional, then the derivative dy dx will now be, you start with v du dx minus u dv dx all over v squared. This is how to find the derivative of a quotient, where u is a function of x and v is also a function of x. So if you have a function in the form of fraction, then just have it in mind that it's a must to start from v. It's a must to start from v. Then you pick the denominator, you differentiate the denominator, minus, you pick the numerator, you differentiate the denominator, all over v squared, the denominator squared. So, but in case of the product that we discussed yesterday, where we have y is equal to u over v, the derivative dy dx is just u dv dx plus v du dx. So when we have product rule, the order of arrangement is insignificant, does not matter. But when it comes to quotient rule, they must to start from v. The formula must start from v. You must start from v. Then we have subtraction sign there. But in case of product rule, you can start from anywhere, and it's just addition. We have addition sign here, so we can start from anywhere. So let's just take example under product rule. Example. Let's say example. Where the question says we should find the derivative. Find the derivative, or differentiate, find the derivative of y is equal to x plus 1 all over x minus 1, where x must not be equal to 1 at the denominator. Okay, let's look at this problem. What do we have here? Let's look at this problem. Y is equal to x plus 1 all over x minus 1. What you do is that you represent the numerator as u, which is x plus 1. Then you represent the denominator as v, which is x minus 1. That is the first step. So you differentiate both the numerator and the denominator with respect to x. So du dx will now be, when you differentiate x, you are going to get 1. Differentiation of constant is 0. Dv dx will also be 1. So what is the derivative? Dy dx, which is the derivative, will be v du dx minus u dv dx all over v squared. That is what we are going to get. All over v squared. That is what we are going to get. Then dy dx, what we are looking for will now be, what is v? V is x minus 1 multiplied by du dx 1 minus u is x plus 1 multiplied by 1 all over x minus 1 squared. So if we simplify this, we are going to have x minus 1. Then in this case, we have minus x minus 1. So x will cancel x all over x minus 1 all squared. Finally, the answer will now be dy dx. Dy dx will now be minus 2 all over x minus 1 all squared. So this is what will be our final answer. So if you are given a multiple choice question, just look at the formula. In the twinkle of an eye, you'll be able to get the answer. So that is what you do. That's how to go about this. So We can get another example. We can take another example on this, or let's just take another example. Example 2. So I want us to take to consider simple questions, because we will be dealing with multiple choice question where we have 2x all over x squared minus 4. This is another question. So in this case now, you go ahead and find the v dx and the u dx. U will be the numerator, which is 2x. Y v will be the denominator, which is x squared minus 4. So here now when we differentiate 2x, we are going to get 2. When we differentiate x squared, we are going to have 2x. The differential of constant is 0. Then this is the formula. Just come to this place and substitute. Just substitute for the value of, just substitute for x. That's what we are going to do here. In this example now, the y dx will now be v. V is x squared minus 4, okay, multiplied by the u dx is 2, minus u is 2x, multiplied by the v dx. The v dx is also 2x, okay, all over x squared minus 4 all squared. If we open up at the numerator, we are going to have 2x squared minus 8. Then this will control this. We have minus 4x squared all over x squared minus 4 all squared. It's not compulsory you open up the denominator. 2x squared minus 4x squared, that will be minus 2x squared minus 8 all over x squared minus 4 all squared. So finally, the y dx will just be minus 2 can come out, so that we have x squared plus 4 all over x squared minus 4 all squared. So that's what we are going to get. That is what we are going to get as our final answer. That's what we are going to get as our final answer. So let's have it in mind that if you have multiple choice question, then this formula is important. We must know. We should be able to record this formula at any point in time. So that is important. It is important to note that we should be able to record the formula at any point in time. Then we can also talk about implicit differentiation. We talk about implicit differentiation. You know, all the differentiation that we have considered, you realize that the value of y is at one side. Every other thing that we have at the right hand side are the function of x depends on x. Y is dependent. But when we have implicit differentiation, the is the case. In case of implicit differentiation, what do we mean? What do we consider? Under this implicit differentiation, we can have both x and y together. They can be in form of addition or as a product of x and y in a particular question. So if you have this type of question, how do we differentiate? For instance, when the question says, let's consider this example where we have differentiate. The question says differentiate x squared plus y squared is equal to 4. So you know, in this case now, at left hand side you have both x and y, both dependent and independent variable. So if you have this type of question is under implicit differentiation. What do? The normal thing is that we differentiate x squared. This will give us 2x plus, if you differentiate y squared, the 2 will come down, subtract 1 from this, it will be 2y. But because y is dependent variable, whenever we differentiate y, we add dy dx to it. The differentiation of the constant is 0. That's what we are going to get. Okay? We can transfer this to the other side so that we have 2y dy dx to be equal to minus 2x. So of course we are looking for the y dx. Then we divide both sides by 2x. We divide both sides by 2y. We divide both sides by 2y. 2y will take care of 2y. 2 will cancel 2. Finally, dy dx will be equal to minus x all over y. So in case of implicit, we can have the value of both. We can have the value of both dependent and independent variable at one side. So I want to take note that when we have implicit differentiation, we can have the value of both the dependent and independent variable at a particular side. So please let's take note of that. So we can have question of this one. We can also it's possible to also have question in this one. We can also have another. Let's pick another question. Let's try and look for simple question, because most of the time all these elementary mathematics are multiple choice. They are multiple choice question. if you are to differentiate x plus y all squared is equal to 5. So what do we do here? Just go ahead and expand this. We are going to have x squared plus 2xy plus y squared is equal to 5. So what do we do here? We just differentiate this. If I differentiate x squared, I'm going to have 2x plus, now look at, in this case now, there are product, this is a product of two functions, 2x and y. So I'm going to apply product rule on this. If I pick 2x, I'm going to differentiate y, that will be dy dx. Plus, I'll come back and pick y, I'll differentiate 2x, 2x is 2, that will be plus 2y. Then plus, where I have this, I have 2y dy dx. The differentiation of a constant is 0. Please, let's note, whenever you differentiate y, you must add dy dx to it, because y is dependent variable. So that's what we are going to get. Look at, when I differentiate x squared is 2x. But in this second component is the product of 2x and y. So if I pick 2x, I'm going to differentiate y, which is y dx. Plus, we apply product rule here. You know, other product rule. If you have uv, you pick the first one, you differentiate the second one. You go back and pick the second one, you differentiate the first one. So I apply the knowledge here. When I pick 2x, I differentiate y, which is y dx. Plus, I will now come back and pick y. If I differentiate 2x, it's going to be 2. 2 times y, 2y. Then differentiation of y squared is 2y squared. So I can collect like times here. That is, I can say dy dx. What is common in dy dx is 2x plus 2y. I will transfer every other thing to the other side. That will be minus 2x minus 2y. So I can divide both sides by 2x plus 2y. I will divide this side by 2x plus 2y. This will take care of this. At the end of the day, dy dx will not be equal to, if you check the numerator very well, minus can come out. Minus can come out of the bracket, and once minus comes out of the bracket, we are going to have plus here. Okay? This can cancel this. At the end of the day, the value of dy dx will be minus 1. The value of dy dx will be minus 1. So please, let's take note. The value of dy dx will be minus 1. So that is that about implicit differentiation. That is that about implicit differentiation. So we can also talk about derivative of trigonometrical functions. That is, you know, yesterday we established the fact that we have so many types, we have some special functions. We have so many functions. We have transcendent functions, polynomial functions, exponential functions, logarithmic functions. We have trigonometrical functions. So let's look at how do we differentiate the trig functions. So we can call it the derivative. The derivative or derivative of trigonometrical function. Trigonometrical functions. Okay? We can call it derivative of trigonometrical functions. Of course, for us to be able to deal with these trigonometrical functions, you must be familiar with the trig identity. Now we know Pythagoras theorem, we know SOHCAHTOA, sine, opposite of hypotenuse. We must be familiar with trigonometrical functions. So, but if y is sine x, if y is a function, is a sine of an angle, then dy dx we got to cos x. You see, we have standard integral tables. You can check standard textbooks. We are going to come across standard integral tables. Okay, we have standard integral table. Then if y is equal to cos x, then dy dx will be equal to minus sine x. Okay, then if y is equal to tan x, then dy dx will be equal to sec square x. That is what we are going to get. So we should note all this, because if you have problem under multiple choice question, they can ask the question can be that if y is equal to sine 2x, what is the derivative? Or find dy dx. We are going to see the implication as we proceed in this revision. Okay, that is that about sine, cosine, and tangents. Of course, we can have the reciprocal of sine, we can have the reciprocal of cosine, and we can actually have the reciprocal of tan. That is, we can also have y to be equal to cosec x, cosecant. That is cosecant. So if y is cosec x, then dy dx, we have all this in the standard textbook. Standard integral table. We got to minus cosec x cot x. And of course, we can prove all this using differentiation from the first principle. Everything we have on the board, we can prove it. By the time we use differentiation from the first principle, we can actually prove it. If y is equal to x tan x. If y is equal to cot x, then the derivative, which is dy dx, will be equal to minus cosec square x. So please let's note the following. Let's note the following. You have all this at the back of your forget table, and I think the use of forget table is allowed, provided you didn't put some additional information. Okay, so but of course you can at least you should be able to memorize. So if the question is multiple choice question, it is very easy. You will know what to do. But if it is the theoretical question, then there's need for us to be able to show all this. Okay, so these are some of the concepts that you should be able to understand when we are dealing with derivative or differentiation of trigonometrical functions. Okay, so if this is taken, then I can go ahead and give example. Let's take 2 or 3 examples on this. Let's just take 2 examples. Let's take 2 or 3 examples on this. We can say that find the derivative of the following. The first one, A, when y is equal to sine 6x. Then we can also have y is equal to tan 4x. Then C, we can talk about, we can have question in the form of, say, cot 1 plus x. Okay, so how do we solve this? Look at the first one. If y is equal to sine 6x, of course, without going through any stress, I know that the derivative of this is 6 cos 6x. The answer will be 6 cos 6x without going through the process. But let me just show you. Let me show the process here. I'll just write the answer in the remaining question. So, sine x is equal to, when the derivative of sine x is cos x. But here now, the coefficient of x is not 1. In that formula that I gave, the coefficient of x is 1, 1, 1. But here, the coefficient of x is 6. So, you just use, you can say let u is equal to 6x. So that du dx is equal to 6. Okay? Then y will now be equal to what? Sine u. Of course, du will now be equal to cos u. So what is dy dx? Dy dx will be du dx multiplied by dy du. Okay? That's what I'm going to get. Then if that is taken, what is du dx? Du dx is 6 multiplied by dy du. Dy du is cos u. At the end of the day, we have 6 cos u. We have 6 cos u. But we are given the equation in form of x, not u. So we now record that u is equal to 6x. We now say 6 cos 6x. So that is dy dx. So without going through this process, how do I get the answer? The only way to get the answer is that differentiate what you have here, 6x. If you differentiate 6x, we are going to get 6. Then what is the derivative of sine? It's not cos. Then this will be cos 6x. Okay? That's how to do that. If you have multiple choice question that you don't have all the time in the world to solve, that is the logic. Now, in this case now, let's look at this second question now, where we have y is equal to tan 4x. Then dy dx will be, when you differentiate 4x, we are going to get 4. Then what is the derivative of tan? When we have tan, what is the derivative? The differentiation of tan is sec squared. That will be sec squared 4x. That's what you are going to get. So without going through the whole process, just differentiate what you are given. Then you just have to be conversant with, you have to be conversant with the derivative of all these sine, tan, sec, cosec. Then there won't be any problem. In this case also, differentiate what you have here. That is, say let u equal to 1 plus x. So that du dx is equal to 1. Then y is equal to cot u. What is the u? The y du? The y du will be, when we say when we find the derivative of cos, cot, the derivative of cot is minus cosec square x. So here we are going to have minus cosec square u. So that at the end of the day, dy dx will be du dx multiplied by dy du. And if you do that correctly, if you substitute correctly there, we are going to have from there if you substitute correctly, we are going to have dy dx to be equal to du dx. Du dx is 1 multiplied by dy du minus cosec square u. Finally, we are going to have minus cosec square u as our answer. Then what is u? 1 plus x. So the final answer is minus cosec square 1 plus x, and that will be the final answer. So under trig function, we should note the following: that when we have trig function, we should note the following. So it's very simple and straightforward. And of course, we can also have quotients. We can have products under trig function. We can have question in the form of quotients. We can have question in the form of products. So let's take one more example under trigonometrical functions. Let's take one more example. Once we have question under products, we know what to do. If it's quotient, we know what to do. Just apply quotient rule and product rule. So let's just take one more example under this. So what do we get here? So the question says that we have to differentiate y is equal to sine x, let's say cos x. We have to differentiate y is equal to cos x over sine x. So this is the form of fraction. So automatically dy dx will be v du dx minus u dv dx minus u dv dx all over v squared. So in this case now, what is u? U is cos x. The v x. What is u dx? Du dx will be y dv dx will be cos. So what is the final answer? We just substitute. Dy dx will now be v. What is v? V is sine x into bracket multiplied by v du dx. Du dx is cos x minus what is u? U is cos x into bracket dv dx. dv, the question is the simplification is v is cos x du dx v, this is wrong, this is v du dx. Du dx is minus sine x, then minus what is v? V is sine x, no, u is cos x, this is x minus cos x is bracket, this is u is cos x, then the v dx is cos x all over sine x all squared. Of course, we are going to see the implication now. We see the implication of that now. This will be equal to, we are going to have is equal to sine x times sine x, that's minus sine square x, minus cos x times cos square x all over sine square x. We can bring out minus at the numerator. That is, we have minus into bracket sine square x plus cos square x all over sine square x. But if you recall that the fundamental identity, sine square x plus cos square x is equal to 1. So at the end of the day, our answer will be minus 1 all over sine square x. That's what we are going to get. Okay? That is what we are going to get. So please, let's take notes. So after this, I'm going to introduce exponential functions. Okay? Derivative of exponential. Here now we want to talk about exponential functions. So exponential functions. So how do we find derivative of exponential functions? That is what we are about to do now. If y if y is equal to e raised by x, then dy dx will also be equal to e raised by x. It's the same thing. If y is e raised by x, exponential function, dy dx will also be e raised by x. But where we are going to have difference is when the coefficient of x here, you know the coefficient of x here is 1. But what if the coefficient of x is like -5 or 7? Then that's when we have the implication. But note generally that if you want to differentiate exponential function, you use the coefficient that you are given here to multiply. If you want to integrate exponential function, you use the coefficient that you have here to divide. Let's note that. Because when you are dealing with multiple choice question that require that we don't have enough answer, enough time to do the calculations, just look at the question and tell us the answer. That is the advantage of what I just said now, the statement I just made now. If the coefficient of x here is not 1, if you want to differentiate the exponential function, differentiate what we have there. Once you differentiate the power, use it to multiply. That is the answer. And if you have to integrate the exponential function, differentiate the power, use it to divide. That will be the answer under integration. Okay? For differentiation, you multiply. Integration, you divide. So let's see example. Let's just take two examples on this. Let's take 2 examples on this. Differentiate, or the question will say find the derivative. It's still the same thing. Differentiate. Number 1, y is equal to e raised by 3x. Then another one where we have e raised by tan x. Okay? So what do we do? How do we get this problem? The first one, y is equal to e raised by 3x. Okay, let me just follow the process. But I've told us what to do. If you want to differentiate this now, just say differentiate 3x. 3x will be 3. Just use 3 to multiply. That will be the derivative. But let me just show us the process. You say let u is equal to 3x. So that du dx is equal to 3. Then y will now be equal to e raised by u. So that dy du will be equal to e raised by u. At the end of the day, dy dx will be equal to du dx multiplied by dy du. And that will be 3 multiplied by eu. That will be 3 multiplied by e raised by 3s. That's the answer. So instead of going through all this process, if you have multiple choice question, just differentiate the power. Once you differentiate the power, use it to multiply the result. That will represent the derivative without wasting any time. In this second one now, we have e to be equal to tan x. So what is the derivative of tan x? Sec square x. So without going through any steps, I can just say dy dx is equal to sec square x exponential tan x. That will be dy dx. But that will be the answer. But let me just show it so that it won't be as if I try to jump step. Let me just show how I got this answer. Then we call it a day. We continue from there. We continue the division from there tomorrow. Okay? In this case now, if this is the question, I will say let u is equal to tan x. Then what is du dx? Du dx is sec square x. Then y is equal to e raised by u. dy du is the same thing as e raised by u. So dy dx will be du dx multiplied by dy du. So from here, what is du dx? Du dx is sec square x multiplied by what is dy du? Eu. At the end of the day, we have sec square x exponential tan x. That's what we are going to get. That is what we are going to get. So if you have exponential function, if you have to differentiate the exponential function, just differentiate the power, use it to multiply. If it is integration of exponential function, differentiate the power, use it to divide. And that is that about that. So I would love to stop here because of our time. We are going to continue from there in our next class. Thank you.